have multiple plots in one single window. So let's see how we do it. So here, let's look at plot 1. So this one is consumption as we did earlier. And let's look at the data. So that gives me some data. You can always do a zoom and you can look at the data. You can basically expand this graph, or you can reduce this graph to see what kind of pattern we have in consumption. Similarly, we can basically choose date being x-axis, my consumption being y-axis, right? So this is being more specific, because here we have a range, but it really does not give me enough information. So I will basically give x-axis, y-axis. I will give the name, that is daily totals, and then I will basically give consumption, color, and y limit based on my minimum and maximum limits. So let's do this. And now we can look at the data here. So let's see, this data makes a little more meaning because we are looking at the dates. And let me do a zoom. So it shows me all the dates. It shows me the data points. It shows me how the data pattern is changing for consumption. Now, this is for consumption. So what we can do is we can also extract specific data. So if you see here, I have done some testing where I'm saying, okay, I would want to get a date specifically. I would want to extract some value. So we are looking at the date column, but if you remember, we did not change the data type. We just changed the data type of date column. We extracted year, month out of it. It would be good if we can convert a column into date time format and put that in our data frame. Now, let's look at the plot 2. This is mainly for your column, which should be consumption and wind and solar. So here I see it is solar data, and I can plot this one to see how it looks like. And that tells me from 2006 onwards, we have some pattern. I can be more specific where I say I would be giving date and then the column for solar, x-axis, y-axis, what is the type, what is the y limit, and what is the color. It is always good to specify your x and y axis, give a name, rather than let it automatically pick up. Now this makes more meaning because it shows me some dates. Similarly, we can do for wind. So either you do it just by giving the column, or you give your x and y axis. So let's look at this one. And this shows me the data. So we can choose plot 3. This one, we can choose plot 2. We can choose plot 1, and we can put all that data in one graph. So that's when you are putting in multi plots in one particular graph. You can always do a zoom. You can always look at the data, right? And this is usually useful to look at the pattern, what kind of pattern we see, what data we have, and so on. Now, moving forward, so we have seen how you are creating these plots all in one window. Let me reset this back to one plot per window. And let's basically plot time series in a single year. So what we have seen is that when you look at the plot method, it was quite crowded. Then we looked at solar and wind. And if you compare that, you will see your consumption pattern, your solar pattern, your wind pattern, and basically we can see from this particular data some kind of pattern. So electricity consumption is highest in the winter, where we will see what is the consumption. Is it highest in winter or is it in summer? We can see that by breaking a year further into months. We can see that, but we see a pattern which goes for every year or every 2 years being highest at a particular point of time, and then it drops down. So electricity consumption is highest in winter, and that might be due to electrical heating and increased lighting usage, and lowest in summer. Now, when you look at electricity consumption, appears to split into two clusters. We can always look at the consumption, one with oscillation centered roundly around 1400 gigawatts. So you can always look at 1400 gigawatts and you see all the values here which are in that particular consumption. another with fewer and more scattered data points, centrally roughed around 1150. So if you really expand this, you can see you will have a lot of data points at this point. Now, we might guess that these clusters correspond with weekdays and weekends, which we can see if you break that data into yearly, monthly, weekly, and so on. Now, if you look at solar production, that is highest in summer when sunlight is most abundant and lowest in winter. So obviously when you're making or gathering some insights, when you're looking at the data, you are also using your domain knowledge, your business knowledge, your knowledge of business to understand how this goes. If you look at wind power production, that's again highest in winters and drops down in summer. So due to stronger winds and more frequent storms, and lowest in summer. So there is some kind of increasing trend in wind power production over years, which we can see here over the years. And all the time series data what we are looking at is referring or showing us some kind of seasonality. That is, we are looking at seasonality in which a pattern is repeating again and again at regular times, at regular intervals. So if you look at consumption, solar, and wind time series, that oscillates between high and low values on a yearly time scale, which we can break down and see. I'll show you that. It corresponds with the seasonal changes in weather over the year. So seasonality does not have to correspond with meteorological reasons. For example, if you look at retail sales data, that will show you yearly seasonality with increased sales in particular months. So seasonality, when we say, can occur on other time scales. So the plots what we are seeing here, they are fine, but if you look at those plots, they might show some kind of weekly seasonality also. So in your consumption corresponding to weekdays and weekends. So let's plot for one single year. Now, how do I do that? So first is I will look at my data 2. That shows me the structure. It shows me date, which is factor, other columns, which are all numerics. Now, like we did earlier, I'll repeat this step where I'm going to convert the date column into date type, look at head of it, look at class of it, look at the structure of it, right? And then what I want to do is I want to add this to my data frame. So I will create a variable called mod data, and this one will have as data, and I'm formatting the value of X, which is date time, into month, day, and year. So let's do that. And now you look at the mod data, which I created, like modified data. So this is the format I have. It is in date type, if you carefully see here. And then I can look at the head of it. So it says me mod data. Now what we did here is when I said my data 3. So my data 3, we did a cbind and I did a mod data, which is going to add this column to my other columns of my data 2. So my new data frame is my data 3. Let's look at the structure of it. And you see there is this date column. I can delete it, I can remove it, I can let it be, right? So that depends on our choice. Might be we want to, once our analysis is done, we want to remove the mod data, right? So we can keep both of them. Now let's basically extract data for a particular year. Now how do you do that? So this is some wrangling. So I will say my data 4, let's call it my data 4, and I will use subset function. So subset will work on my data 3, that's the data. And what I'll do is I will do a subset. How is the subset found? So I'll say take the mod data column, the value should be greater than or equal to 2017 and should be less than 2017 December 31st. So I'm getting data for 1 year and I'm storing it as my data 4. Let's get the head of it, and you see we are specifically looking at 2017 related data. Now let's do a plotting of this where I will only create a plot for 1 year. So I'm saying my data 4, that's my new data what we got. So here I am going to take the first column, which is mod data. I'm going to take the third column, which is consumption. So I'm looking at the date format for 1 year, consumption values for it, and then rest of the things as we have done earlier. Let's look at the plot, and this makes more meaning, right? So when you look at this plot, it tells me Jan to Jan. It shows me some kind of pattern where I have divided the year into months, right? And it is broken down into, say, 2 months, so Jan and March and May and July and so on. But we still see a pattern, and that gives me good understanding of pattern where I've broken it down into months. So this is where you have taken time series in a single year to investigate further, and this is what we see, right? Now we can clearly see there are some weekly oscillations. What one more interesting feature is that at this level of granularity, that is when you're looking at yearly data, there is a drastic decrease in electricity consumption in early January and late December during the holidays, or probably we can assume that this is holidays. Now I can zoom in further and look at just Jan and Feb data. Let's see how we do that, and let's see how we work by zooming in the data further. So to zoom in the data further, let's see how we do it. Now here we have this my data 4, which is basically having a subset, right? So let's work on this one. So I will say my data 4, which earlier I was taking data 3, I was doing a subset and I was giving the date, but this time I will make it more narrower. So I'll say my data 4, I will say subset from my data 3, and I will choose mod data column, which we have modified with the date format. I will choose the starting date as 1701, that is Jan, and then let's go till Feb, and let's create this. Now let's look at the head of this. So it shows me we have the data which is Jan, and then you can basically look at more on this. Now again, as I said earlier, let's find out the minimum of this from the first column. So that is basically your mod data. So let's look into this one, and that basically will give me minimum and maximum. Let's look at the values. So this one tells me Jan 17, January 1, and maximum is your Feb 28th, second month, 2017. So we are actually looking at 2 months data here. Let's look at the Y minimum. So this is, I will look at column 3. Now what is column 3? Consumption. So let's look at the minimum value for consumption, maximum value of consumption. Let's look at the values which can be given as our limits. Now this is the minimum and maximum. Now let's do a plotting for this data which has been narrowed down for consumption based on my data. So I'm saying my first column, which is mod data, and then third column, which is consumption. I'm giving some naming convention for, namings for your x-axis, y-axis, what is my consumption, or what is my title here, what is the color, and then you see I'm using X limit to give the minimum and maximum limit and Y limit. So let's look at this data. And if you look at this data, it is specifically for 2 months. And again, I can look at the pattern here. What I can also do is I can add some grid here. So I can basically look at this data and make more meaning out of it. So it is bi-weekly data, you can see. Now I can add a line here using ab line, and then I can basically choose what lines I would want to add horizontally. So that basically allows me to dissect the data and look at data in a more meaningful way. I can also add vertical lines. So vertical lines is, I'm saying sequence will be minimum, maximum, and I'm saying an interval of 7. So let's do this. And this basically has added some lines every week. And you can see at the end of week, it is dropping and then it is starting again. It peaks somewhere in the mid of the week and again it drops down. So this is, you're looking at your consumption data, right? Now what we can also do is we can create some box plots. So when we looked at zooming in data for Jan and Feb, you can add some data points like this. So consumption is highest on the weekdays, as I showed you here, and lowest on the weekends. So this is what we are seeing when we are breaking the data or zooming it further for a couple of months. So we have vertical grid lines, and we have nicely formatted tick labels, that is Jan 1st, Jan 15th, Feb 1st, and so on. So we can easily tell which days are weekdays and weekends with use of these grid lines and basically breaking it down. So there are many other ways to actually visualize your time series data depending on what patterns you're trying to explore. You can use scatter plots, you can use heat maps, you can use histograms, and so on. Now, moving further, we would want to explore the seasonality, right? So when you further explore the seasonality of our data, we can use box plots basically to group the data by different time periods and display the distribution for each group. Now, how do we do that? Let's come here and let's see how box plot works. So I can just do a simple box plot and I can choose my consumption column, and that gives me just the consumption data, but this really does not give me any meaning. I can look at solar data, I can look at the wind data, and we can also see some outliers here. So we can create box plots, but if we would want to do a box plot, what is box plot? It is basically a visual display of your 5-number summary. That is, you want to look at your mean, median, you want to look at your 25th percentile, 50 percentile, or 75th percentile. So we can use a quantile function, use the consumption column, and then you basically give a vector which shows you 5-number summary. So that's your quantile. And then let's do a box plot. So if you are looking at quantile, it tells me what is the minimum, what is 25th percentile, 50, 75th, and 100. That's from my consumption column. So let's create a box plot for consumption. Let's give it a name as consumption. Let's give y-axis as consumption and a limit for y-axis. Now that's my consumption graph. So I can look at yearly data. Now that will make more meaning rather than just looking at the complete consumption data. So how do we do it yearly? So we will say consumption, and then I will say the year column. So it is consumption, but grouped based on year. So here I can give x-axis, y-axis, and I can give y limit. So let's create this, and this makes more meaning. We can give some coloring scheme here, but now I'm looking at 2006, 2007, 8, 9, and so on. And we can look at the data. What is the range, right? It gives me 5-number summary of the data per year, and it basically allows me to look at the seasonality of this. Similarly, we can create box plot by just giving consumption, yearly grouped, and here I'm giving the title as consumption, y-axis, x-axis, and y limit, wherein I can also use las. So this is one more feature which you can do, and that basically will give me the tick points. If you compare this one to the previous graph, so when I created this previous graph, I had 2006, 2008, and I had from 600 to 1800. And if I go for the next one, I am basically seeing more useful information. Now let's look at monthly data. So I would want to group it based on months, and let's create that. So this gives me the monthly data where I'm looking at months, and I could select a particular year, or I can just do a grouping based on months. So I can have multiple plots to see a difference here. So let's do this. Now let's create a box plot for consumption, which is monthly data, and let's give it a color. Let's look at the wind data, which is again grouped monthly, and let's look at the solar data, which is grouped monthly. Now, if I zoom in, it basically gives me the seasonality of the data for your wind, for your consumption, for your solar. So what we are doing is we are creating these box plots which are giving us values. Now what I can also do is I could look at the day wise also. But before we look into this, how do I infer some information from these box plots which are being created? So this is what we have done, where we are looking at the data for month, and these box plots give me year seasonality, which we were seeing in earlier plots, but give some additional insights. So if I look at the data here, it tells me the electricity consumption is generally higher in winter. Now, this is based on months. So we can see consumption is higher in winters and lower in summer. So we can obviously look at our plot. We can see where it is lower, where it is higher, and then we can look at the median and lower two quartiles are lower in December and January compared to November and February. So that is, you look at the quartiles and you will see that the median and lower two quartiles are lower in December and January. Here Jan and December, so you can look at from my plot. Now this is giving you some idea on seasonality. Now, that might be due to business being closed over holidays. Now, this one we were also seeing when we looked at time series for 2017 only, and box plot basically confirms that there is this consistent pattern throughout the years. Now, when you look at your solar and wind power production, both will give you a year seasonality, what we are seeing here. And if basically I look at the data, so it depends on what parameters you are choosing, but if you look at solar, it will reflect the effect of occasional extreme wind speeds associated with storms and other transient. And since we are grouping it based on months, we can see this pattern is quite evident every year. Now, what we can do is we can group the data day wise. So here, let me again reset this to one plot per graph. Now I'll say box plot. I'll say consumption, which is grouped based on day. Now we know that there is a day column, and let's give a while limit and let's look at the data. So this is where I'm grouping the data day wise. So you look at 31 days and you look at the box plot. So this is where you are plotting it on a daily basis. So you can look at the data, you can break it down to a particular week. So here I have given day and I have chosen all the 31 days, but I can break it down to a week and I can look at the data. So if we look at the data per week or per day, we can basically infer that electricity consumption, where I'm doing a consumption group by day, is higher on weekdays than on weekends. So time series with strong seasonality can often be represented with models that can decompose signal into seasonality and long trend. Now this is an easy way. Now, how do we look at the frequency of the data? That could be interesting to see. So let me look at, say, the yearly data, which we were seeing here. Now let's go further, and here we have looked at data. So what we will do is we look at the frequency. Now when you look at the frequency, when you talk about frequency in your data, so we have the modified date column, which gives me a frequency. And if we really look into the data, that will tell me that the data is on a daily basis. So for that, let's look at my data 3 again, which gives me data, and you can just see all the data or dates are in sequence. So your 22, 23, 24, 25, 26, and so on. I can access a dplyr package that is basically allowing me to work in a better way. Now I can look at the summary of this, and for all my columns, I'm seeing what is the minimum 5-number summary, date, and consumption. So date does not show me anything because this is not in a date format, it is just a factor, but other things have the 5-number summary. So we are looking at wind plus solar, we are looking at year and month and day and all these columns. Now what we will do is we will want to find out the sum of each column, how many entries does it have, and we will say the value should, NA value should not be considered. So let's look at this one. So it tells me for my particular columns. So let me run this again. And that shows me for each column how many values you have, and these counts do not include the NA values. Now similarly, I can find out specifically for consumption. I can find out, is there any NA value? So I'm saying is.NA, and let's find out if there is any NA value or missing value in consumption. It says 0. Okay, that's good. If you look in wind, it tells me there are 1,463 entries which are NA. Similarly, solar, similarly, wind dot solar or wind plus solar. So it gives me a count of NA values, that is missing values, and also values which are not missing. So to understand frequency, what we can do is we can find out the minimum on the date, that is the first column, and I'm saying RM NA.rm is true, that is get rid of NA values and find out the minimum. And let's look at the minimum value. This is the minimum from my modified date. Now if I would want to get the frequency, I can basically use sequence function. So I can say from X minimum, that is the minimum value, I want to look at the frequency, that is day wise, and let's just look at 5 entries and see if there is a day by day frequency. So let's look at the value of this, and obviously it tells me there is day wise frequency. So that allows me to look at the frequency, look at the type of it. It is an integer, class is a date. So similarly, we can say from X minimum, we can basically look at the frequency month wise, and I can again look at 5 records. So that shows me monthly data, right? So I can extract the data for frequency, similarly yearly data, and that's also very useful. Now we can select data which has NA values for wind. So how do I do it? I would want to find out the wind column, and I want to find out where the values are NA. So I will create a variable, and here I will say my data 3, and then I give a conditional where I say is NA in the column. So let's do this. Now once I've done this, I have said that my selected wind data from my data 3, where we said NA values, and I will give the names to this. So names should be in my data 3. I'm interested in mod data, consumption, wind, and solar. So these are the 4 columns I'm interested in. Let's look at first 10 records here, or first 10 rows. So that tells me these are the values where wind has NA or missing values. I can always do a view, and that gives me the complete data. So it basically shows me 1,463 entries, and here it shows me all NA values. So you can look at all the way to the end, and it shows me wind has NA. Solar does have some value here in the last row, but then also if you see, the numbers have a difference. So you have 1461 and then you have 2174. So there is a difference. So there is some data in between where wind has some values. So we have found out NA values. Now what we will do is we will select data which does not have NA values. So I will call it cell selected wind 2. I'll again use my data 3. I will say which, but now I'm saying not NA from this column, and I will select the data for the columns. So I'm interested in looking at 10 records, and this shows me not NA values, so no more missing values. So if I really look at this data as I saw earlier, which has NA, and if I look at these values which are not NA for the wind column, so looking at these two results, we will know that in year 2011, wind column has some missing values. So let's focus on year 2011. So how do I do that? Let's call it a different variable. I'll say my data 3. I will say here, when I say which, where we were saying NA, here I will say the year should have a value of 2011, and I want all these columns. Let's look at the data here, and this is showing me 2011, but we are not seeing all the values. So there are some values, but then there are some missing values also for 2011 based on whatever analysis we have done. So let's look at the class of this. It is basically a data frame, do a view, and this one will help me in finding out where are the NA values. So if you just scroll down, looking at all the data, let's search if wind column has a NA or a missing value, and I will see if there is any missing value, in which column or which row it is for the wind column. So we have all the values which are existing. I could select and search for one specific value, and I'll show you how we can do that. So here, let's scroll all the way down. So it's like you're exploring your data and seeing, is wind column having NA or missing value for a particular row. And let's scroll here, and here you see there is a missing value for one particular row. So 13th December 2011 has wind value, 15th December has wind value, but your 14th December does not have, right? Similarly, we can search. So there was only one entry which was missing. Now that could be for some reason, might be it was not calculated, might be it was not tabulated. So we have a missing value, and that can affect my plotting, that can affect my analysis. So let's look at the number of rows in this, which will tell me how many rows we have for 2011. So it tells me 365. So that is basically the number of days in a year. Now we will find out if there were NA values. So we earlier checked total number of NA values per column. That is in your row number 265 to 269. We can see here 265 to 269. So this is where we were seeing, are there any NA values, right? So let's go back here, and we want to find out the number of NA values for a particular year. How do I do it? So I can just do a sum. I will say is NA. Now I'm interested in my data 3 wind column, and I'm saying my year has to be 2011, but I'm finding out the NA values. So let's do this, and it tells me 1, and that's right. That's what we saw when we did a view. Let's see how many non-NA values you have, and that is 364. So that basically satisfies my logic. So it's 364 plus 1 missing, so there are 365. Let's look at the structure of this. It tells me you have modified date and date format, you have consumption, wind, and solar. Now let's create a variable, selected wind 4. I will say wind 3, that is which was having all my NA and non-NA values for 2011. I will say let's find out the NA value, because I'm interested in finding out that particular row. So I'm saying find out where the value is NA, and I want all the columns. Let's look at this one, and this is my specific row which has a NA value. Now we know that data follows a day-wise frequency, which we have clearly seen. Now let's select data which has NA and non-NA values. So let's say, let's call it test 1. I will use wind 3, which has NA and non-NA values. But now I will say I want the modified date, which should be greater than 12/12/2001. Now remember, we had, when we were doing a view, we saw that one particular day, or what we see here, 14th of December, there is no date. So I will select a subset of data which includes this NA and non-NA. That is, might be I can take 13th of December and 15th of December. So let's start from 12/12. So the date should be greater than 12/12. That means 13th, and it should be less than 16th. So that is 15th, and the columns, right? So now we have some data. Let's look at this. So I've selected a subset of data. I could have done this using subset also. So I have NA and non-NA values. Now why are we doing this? So sometimes you might have some data for a particular column and you may want to find out if there are any missing values. Might be you want to fill them up or replace them with something. So that is usually useful when you are doing a trend detection. So say for example, you have data for every month and might be in one of the months you have missed, or might be you have data for every year collected monthly, and then in one of the years for a couple of months you don't have the data. Like I can say 2016, I have data for all 12 months, 2017, all 12 months, 2018, might be I don't have data for March and June, 2019, I don't have data for same months. So I can forward fill or backward fill them using the previous year's same month data. So we can do that. So here I have test data where I've extracted a subset of data. I can look at the class of this. It is a data frame. Structure of this, it has the columns. Now let's use the library and function and use the tidyr package. And what we will do is we will fill it up. So I will use test1. I will fill the wind column, which has a missing value. Now, once you do this, if you notice, it has done a forward fill. So it has taken the previous value and it has just filled up that. So you can fill up the data using different directions, such as up and down, left and right, and so on. So we can take care of missing values in our frequency data, which allows us to basically analyze the data in a better way. Now, here we will want to also look at some more data. So this is to deal with frequencies of fill column, wherein you can take care of missing values forward filled. So filling values can be done in different directions, as I said, and you may want to first convert your time series to specified frequency if your data does not have a frequency, but we had. Now, if you do not have a frequency, might be you can convert it into a frequency such as weekly, daily, monthly, as I showed you. And then basically you can do a forward fill for the values. So for example, if I have my data, I can break it down into weekly and then look at the values. And if there are any values missing for weekly data, I can use a forward fill. So that can take care of my frequency data. Then let's look at the trends of the data, which is the last part of this project. So basically, let's look at the trend. So when you say trend, what does that mean? So in time series data, you always have some kind of trend. So that will exhibit some slow, gradual variability in addition to higher frequency variability, such as seasonality and noise. Now, to visualize these trends, what we do is we use what we call as rolling means. So we know how our data is spread over year or month or day. But how about looking at a rolling average and see what is the difference? So a rolling mean will tend to smooth a time series by averaging out the variations and frequencies. So this can be higher than the window size. So there is something called as windowing, where you can choose a set of time frame. You can also average out any seasonality on a time scale equal to window size. So this will allow you to look at lower frequency variation in the data. So when we are looking at electricity consumption time series, we already saw there is a weekly pattern, there is a yearly seasonality, which we saw using box plots. So we can also look at the rolling means of the time scales. How do we do that? So for this, you can use some package like Zoo, and then you can basically use a rolling mean using the Zoo package, and you can say what is the frequency with which you want to calculate the rolling mean. Now, how do we do this? Let's look at this data. So here I'm going to look at my data 3, which we have been using so far. Now let's call it a 3-day test. You can give it any name. I'm going to use my data 3. I'm using the pipe in function. Now I will use dplyr and I will arrange the data descending in year. Now you can always break it down step by step and you can see the result of this. So I'm going to arrange this data in descending order of year. So obviously my last one, 2017 or 2018, will be on the top. You want to group the data by year. So it depends on how many years we have, we'll see. So you can group the data by year. Now this data is then used to basically mutate. So mutate function is going to allow me to use this rolling mean. So I'll call it as says 03 day. So I'm going to calculate a rolling mean every 3 days for my consumption column. And basically let's ungroup this. So let's see how this works. Sorry, yeah, let's look at this. And here when I'm doing a 3-day test, let's look at the result of this and then I'll explain this. So if you see here, we have the test 3-day column. Now this has the rolling average. Now what does that mean? So first value here, what we see is 1367 is the average consumption in 2017 from the first date with a data point on either side of it. That is, you can look at this date, so 1130, then you look at, you are looking at the value 1367 here. So you look at 1130, 1441, 1530. If I take a mean of these, so for example, if I would just do this part, and that is giving me mean, okay, because I have a comment. So let's basically add anything as comment, and then let's do this. So it says me 1367. That's what we are seeing here, right? So you're getting a rolling average every 3 days. Similarly, if you want every 5 days, it takes the 5 values and it gets the mid value, right? So you can always find out the mean, rolling mean for a particular frequency. Now, let's do that for 7 days, that is weekly data, and yearly data, that is 365 days. So how do I do it? Same logic, my data test. Now I'm using my data 3. I'm arranging it in a descending order. I'm grouping by year. So when you do a group by year, so earlier when we did a grouping by, and when we looked at the data, it was telling me how many rows we had, right? So let's do a grouping by year, and let's say test 07. So that's a rolling average every 7 days, and I'm also saying take care of the NA values. Similarly, I'm getting rolling average every 365 days. Might be you can do quarterly, might be you can do half yearly. And let's do this. So let's create this, my data test, and let's look at the result of this. So I will use my data test. I will say arrange based on modified date. Now we know there is a column called modified date. I want to just look at 2017 data. So I'm doing a filter, right? And then I will choose what are the columns I'm interested in. So I will look at the 7 and 365 day. And let's look at, say, first 7 records. So let's do this. And that basically gives me the consumption value, modified date, year, and my rolling 7-day average or the 7-day mean, which is for first 7 days. And then 365, you will not see the data here, but if I do a view on this, I can basically see the values. So you can always select a particular column to see the values. These are the values for every 7-day rolling average. This is for 365 days, every 365 days. So you see all the values are missing, but every 365 entry, you will have basically some data. Now, let's do a plotting of this and basically visualize this data which we are seeing rolling average. So let me first do a plotting, one plot per graph, and let's do a plotting. I will take consumption data, x-axis, y-axis, color, and give a title to this. So let's create this, and that's my consumption data, which is spread over a period of time, and that's fair enough. But now let's add some more plot to this. So I will add the 7-day rolling average to this. So for second plot to be added in the same one, in R you can use points. So I will say points. I will choose 7 data column. Type is line, width, X limit, Y limit, and color. So let's do this. And that's my pattern 7-day rolling average, which basically gives me some kind of trend. Similarly, I can add one more here, and this time I will choose the 365 day and look at the pattern lines. So now you see some dots here. Well, you could do it in a different way. So I can just add legend to this, and I can say legend will be where in x-axis and y-axis. So I'm saying it will be 2500 and y is 1800. So my legend will come in somewhere here. I'm saying my legend will have consumption, test, and this one I can give some names. I can give what is the color. I can say what kind of legend. It explains what is for each color, and then basically a vector. So let's add a legend to this, and I've added a legend. Now you can do a zoom and look at the data, and here I see that my x-axis is fine, but y-axis is going a little out of my plotting area. So I can actually change that. So here I have 1800. How about making it 1600? And let's look at this one. So we can basically go for this one and start again here, plot and points and line, and then add a legend, right? And you can basically place your legend anywhere in the plot. So this basically is giving me the trend, what I'm looking at, my rolling average. So similarly, you can look at the trend for wind and solar data. So what we are seeing here is when you look at trend, this is one more way of looking at it. You can always create plots in different ways. So 7-day rolling mean has smoothed out all weekly seasonality, which we were seeing here in my graph, where you look at every 7-day, preserving the yearly seasonality. So 7-day will tell that electricity consumption is typically higher in winter and lower in summer. So better is you break it down yearly. So here, if you look at every year, you can see when is winter, when is summer, what is the seasonality, what your trend, what you're seeing here, and if there is a decrease or increase for few weeks every winter. So similarly, if you look at 365, now as I said, rolling average basically reduces the variation. So if I look at 365 rolling mean, we can see long-term trend in electricity consumption is pretty flat. Now that's what we are seeing. It's kind of pretty flat. There is not much variation over years if you really join these dots. So we can basically see some highs and lows, and that gives me a trend. Now this is how you can do a trend detection, and similarly we can do plotting for wind and solar. So this is a small project which I demonstrated using R. Now all this code which you have here in the form of a project.r file, you can find here in my GitHub page. This is the document which explains some things. Feel free to download this and you can add details to it. This is the sample data set, which you can also find in my repository in the datasets folder. So continue learning and continue practicing R.
And with that, we have reached the end of day 2 of our data science week. On day 3, that is tomorrow, we are going to learn about SQL for data science. Thank you all for watching today's live session. I hope it was useful and interesting. Thanks again.